Hey there my friends. It's very inconvenient to turn every piece of electronic at my workspace separately on and off. I could just install a manual switch, but the problem is that my speakers then do this. Which is certainly not good for the membrane and the speaker electronics due to some interference. Well, that would be way too easy, and that's why I will use an ESP8266. Yeah? Okay, fine. Oh yeah, some years ago the Chinese thought, well, the Arduino is hell of a beauty. And Wi-Fi would make it so much better. Thus they put an antenna on a normal Arduino, made it much smaller, and the result was the ESP8266. Today you can have it in the ESP32, the Node MCU, the Shelly, and so on. I wanted to be safe and opted for the Sonoff Basic R2. It has a built-in power supply, a relay, and everything is nice and packed. But do you remember what I said in the beginning? When my speakers go all like... For this purpose, my amplifier has this tiny switch. After the power is turned on, I flip the switch, and before I turn the power off, I flip the switch again. At this point we could use a second Sonoff and delay both switches depending on the executing command. Although one Sonoff Basic provides just one relay, the built-in ESP has more pins and 3 of them are easily accessible. Originally we can flash the ESP over 2 of these, but these pins don't provide sufficient power for a relay. So I took some measurements and noticed that the switch pulls 20 volts to ground. This job can also be done by a transistor. At this point I also removed the Bluetooth antenna and used the remaining hole in the casing to mount a cinch socket. Then I soldered the 2 important pins of the switch to it, and this way I can easily connect a cable to it later. Every test with the transistor succeeded, so I came up with this tiny circuit. Both resistors limit the current running into the transistor so it won't get grilled. And the diode protects the ESP pin from the 20 volts. Now that we got this problem solved, we can talk again about controlling mains voltage. Some years back I already built a series of Wi-Fi switches by utilizing old RC casings. These casings provide everything we need. However, the process of connecting can be quite challenging. That's why I made this tiny sketch. But every wall adapter is different, so if you have any issues, please consult a qualified electrician. After I soldered the cables onto the wall plug, I closed it so that the cables are free. Then I drilled a hole into the casing of the Sonoff to lead the 2 cables for the amplifier out of the casing. At this point make sure to follow the connections of the sketch again. Both the Sonoff and the circuit will be mounted on a piece of wood. I also made a tiny casing out of some plywood and painted the whole thing black. Lastly, put all parts together. To warn everybody that I used the earth cable in a different manner, I put some black isolating tape around it. But let's take a look on what we have. The wall adapter plugs into the power line and provides the Sonoff with power. The Sonoff itself can later connect to your Wi-Fi and switch on the power for every device. Over the additional pin and the additional circuit board, it bypasses the switch of the amplifier. So far so good. But what is missing is the software. 4 minutes into the video and we haven't talked about my smart home concept. So let's get right into it. The cool thing is that today we won't have to write a single line of code by ourselves. The foundation of our system will be NodeRed. A simple to use and locally running smart home solution. You can easily put together a dashboard and control your devices on every browser when you are at home. That's why we need a Raspberry Pi or any other server which can run NodeRed. The second asset we will use is Tasmota. This is the software which will run on the Sonoff switch. Once flashed to your device, it is easy to set up. Both devices will communicate over the MQTT protocol. The first thing I did was to flash Tasmota onto the Sonoff device. But I need to be honest, this process was so tricky with mine because the f***ing button to bring it into flash mode was broken. After some exhausting hours of trying, I had the idea to solder the second button onto the old, and after the next hours I had the right settings for the Pi flasher. But I didn't record it. So please follow one of these tutorials you can easily find on the internet. The Sonoff will now create the Wi-Fi, and after connecting with it, this page will open. Click on your home Wi-Fi and enter the password. After waiting for the reboot, we need to configure the pinout of the device. The relay is activated from the beginning, but pin 14 needs to know that he has actually a purpose. Since the relay has the address 1, pin 14 will get a 2. We are now able to control both pins over this page. But as more devices gather up, you need a central. Therefore, we set the parameters for MQTT. We need to enter the IP address of the Raspberry Pi as the server and think about the MQTT topic, which acts like a channel for communication. Well, to actually know the IP address of your Raspberry Pi, you need to set it up first. Thankfully, I already made a video about this topic, where you will also see how to get the IP address. There are now two things we need to install, NodeRed and Mosquitto. Mosquitto will be our MQTT broker managing all messages coming in and out. NodeRed needs to start automatically. We add it as a service. You can see that the service is now available but not running, so we start it. NodeRed takes about 3 minutes to get ready, so be patient. You can check the progress with the status command of a service. After it is done, you can access the web page of the IP address of your Raspberry Pi and adding the port 1880. Next, we check that Mosquitto is running properly. You can later improve the security of NodeRed and Mosquitto by adding users and passwords, but for now this should be enough. The first step in NodeRed is to install the UI palette. This package provides a bunch of different controls, such as the switch. You also need the two different MQTT nodes. In the switch node, we firstly create the group Room and then the new tab Home. The switch gets the name Power, and I also added a little tooltip. The MQTT node forwards a string containing either on or off, and therefore the switch needs to react to these commands. Going forward to the MQTT nodes, firstly create a new server, give it a name and enter the IP address of your Raspberry Pi. Now you need your MQTT topic you made the Sonoff listen to. We have to add the prefix CMND. The number after the power tells which output is meant. The built-in relay is the 1 and we set pin 14 to the 2. Copy all 3 nodes and change the number in the topic as well as the name to audio. Make sure to unmark these checkboxes, otherwise the switches will turn themselves on and off repeatedly. Lastly, we deploy the flow. You can access the dashboard by adding a /UI to the address. And we are now able to control both outputs. For the last part, I want to create the master switch. At this point, we have to differ between the on and the off command. That's why I included a switch node and delayed either the power or the audio for 2 seconds. Lastly, the wake on LAN package provides the node to wake up my computer. Make sure at this point to configure your computer properly for this purpose. But we aren't finished yet. As I said, NodeRed provides the possibility to include Homekit. Through it, we can control the devices with Siri and a Home app. Install the right package, add a new accessory and make up a creative pin code. The last part is a bit tricky because the messages need to be altered with a change node. Copy the rules for the node after the Homekit and the node before it. You can find the button to add new rules at the bottom. On your phone, open the Home app and add a new home. Click Add Accessory and then More Options. Your new Homekit accessory should now appear. After you have chosen it, you are asked to enter the code you created in NodeRed. Lastly, place it into a room. Yeah, finally, we did it! We can now turn on the complete workspace with one click or call to Siri. Did you learn something in the process? Then subscribe, goddammit!